All right, so I'm going to go through a quick tutorial on how to set up and use Fusion 360 to cam a part for getting cut on the CNC. Picking a pretty simple part because it has some holes in it for bolting, a bearing hole, and then an outer contour. To get this part even into Fusion, you got to upload, find the DXF that you're working with, and upload it, and then you can select it from the parts on the left side. So get going. Once you have selected your part and you have it open on your Fusion main window, I'm going to go from design to manufacture, and then I'm going to create a new setup. Right click, new setup. I'm going to change my stock using a fixed size box. And then I'm going to use an 1/8 inch piece of aluminum for this. And so for 1/8 inch aluminum, that's 0.125. It is important though that you actually measure the material that you're cutting, because even if you get an 1/8 inch trust anyways, if you get an 1/8 inch piece of, let's say, plywood, usually that's not dimensionally perfect. Aluminum and polycarb is usually pretty good, but can be a bit off, so you want to make sure you measure it with calipers before. But let's assume that we're perfectly at an 1/8. And then I'm going to also select, because this part is kind of modeled at a weird angle in the CAD, it comes in the orientation that it is in the assembly. So I want to change it so that I can use kind of these right angle sections of my part to be the axes. So I'm going to go, for orientation, instead of model, I'm going to do select my X and Y plane. For my X plane, I'm going to use this line here. And then for my Y plane, I'm going to use this line over here. And I'm going to select that Y plane again, so that I'm going to click this Z axis here to flip that over. I don't like the positive direction there. So there we go, okay. So just had to click the axes until it went to the orientation that I wanted. And then I'm going to select the point where my origin is touching my box. So it's gonna be on the bottom left corner. That way when I set my 0, X, Y, and Z zeros on the CNC router, I can ensure that I have enough material to cover the entire part. So make sure that you bring that axis all the way to the corner of your box, and make sure it's on the top, not the middle or the bottom, but the top section, because that's going to be important for when we set our bit on the part. Okay, so I've done my setup. I have my machine thickness. I have my axes in the right location on my box plot, or on my box stock. Then I'm going to do the holes first. So when we order our operations, it's going to go based on holes first, and then any interior contours, and then exterior contours. That way, the very last cut is actually cutting the part out of the material. So for these holes here, I'm going to choose a drilling operation. So I'm going to click drill here. And then I'm going to select all of the center points for my part to be drilled. Okay, so I had to change to same size diameter and then actually select my boundary constraints here. The heights are going to be, I'm going to make sure that for the bottom height, it's going to be whole bottom, and then I'm going to go an extra negative 0.0125 down, meaning that I'm going to actually aim for slightly below my spoil board, so that I can ensure that the bit goes all the way through my part. And then for the drilling, usually wrap it out is fine. It might, if we have thicker materials or harder materials, we might have to pick a different method, but I think this is good for what we're doing. And then we have to select our bit. And once you get to the filters, We do have a set of bits in the shop, and I actually don't have them set up here, so I will set it up while I'm here. So we have, they're all saved on local machines. So because I had to add the license to Fusion, because you only get one with your email. I had to move it from the CNC computer to this computer. I have to put in my tools again. And so we have a 5mm 2 flute end mill. And then it's a by Gar. And so the cutter itself, it's 2 flute, and it is carbide. The diameter, again, is 5mm. Shaft diameter is the same thing, 5mm. The overall length of the bit is about 2.5 inches, with about an inch and a half being used below the collet. The shoulder length is about, I would say that's about right. And then flute length is 16mm. So I'm gonna pull all that information in here. And then the next part is the cutting data. We use pretty much everything at full speed, and it's 24,000 RPM for our CNC router. And then for cutting feed rate, we're gonna use, for aluminum, we're using about 80 inches per minute. We can go a bit faster when it comes to like wood or polycarb, but we'll set that as like an initial setting, and then go ahead and accept that. And we're gonna select that tool. And then, okay. So now it's showing the tool path, and we could simulate it to see what it would look like. We're showing the tool path, slow that down a little bit, for the drilling operation. And what we see here, it's not actually going through all of the parts, so something was wrong with how we set up our heights. So let's see that again. Let's go to edit. Whole bottom. -125. So we're gonna go to stock bottom, not whole bottom. So stock bottom should give us now the ability to go all the way through the material. So I look at the simulation again, I play that. Now I can see that the hole is going all the way through the material. Exit my simulation. Boom. Now we're gonna do the next one is going to be this bearing hole, which we're gonna use a 2D contour. I'm going to select the same tool. And then, because we're actually going to do this on polycarb, or I assume we're going to do this on polycarb in one of the students who's requesting a cut soon, and I'm making this video for, we're going to do polycarb. I'm actually going to change this to 250 inches per minute. A little bit faster speed because polycarb is just softer. We can cut through it a little bit faster. Select our geometry, which is this hole, and I want to make sure this arrow is on the inside of my hole, because that means the bit is going to come in from the inside and then circle around such that the hole of the part is going to actually be the size of the hole in the model. If I do this, it'll cut along the outside of the hole, which means that the hole is going to be this size plus the diameter of the bit times 2, because the bit is going to be riding on the outside of this radius, or outside of this curvature. So I'm gonna make sure that's on the inside there. And I'm gonna make tabs for it. And usually for things like this, I'll do it by numbers, and I'll do, for a hole, I'll do 2. And then since we have like an 1/8 inch part, I'm going to make my height about 0.045 is about right for that. For my heights, again, I want to go to stock bottom and do -0.0125, so it cuts just a little bit beyond the material into the spoil board. And then for here, I'm going to go multiple depths, so that I'm just shaving off a little bit of material on my way around. So for cutting into polycarb, something like 0.1 is pretty conservative. We can do about a 0.1 cut on polycarb pretty easily. And then I'll press OK, and it'll create that cut. And as you can see, as it does the cut around, it'll show, let's try that again. If I do the simulation of that, it'll go through, I think, 3 or 4 passes based on the height. So, or actually just 2 passes because it's 125. So it goes down 0.1 every single time. So after the second pass, it'll already go all the way through the material. So that's how it does the contour with the tabs. You can see that there's a little bit of material on the tabs that we could cut off later. And then go ahead and exit that simulation. Now the final operation for this is going to be a 2D contour around the outside of the part. Here we want to make sure that this arrow, see as it comes on the inside, we don't want that because that means the drill bit is actually going to be inside our part as it goes around. I'm going to click that so it goes on the outside of the part. Same thing, selecting the same bit, which sometimes if you use the same operation, it'll reload the bit that you were using in the previous operation. So all that stuff still applies. I do want tabs on the outside of this part, and on this case, I'll do 3, just kind of based on the size of the part and how much I expect it to potentially come off of the material as it's cutting. For a larger part, I might use like 4 tabs. Depths are good, tap width is fine. For here, I'm going to go into heights. Again, going to stock bottom for our bottom height. Going to go slightly below the bottom at negative 0.0125. So it's cutting below the actual height of my part. Then I'm going to go to multiple depths. And again, for polycarb, 0.1 is a fine number. So then I press OK. And you can kind of see what the final outcome should be. I can run this part, and it'll simulate the cutting going once around, going the second time around, and there we go. And then I can actually simulate the entire operation. If I click the first operation, press Shift, and then click the last operation, it'll highlight all of them. Then I could simulate the entire thing. So it'll show the hole drilling operations first, and then it'll do the bearing hole, and then it'll do the outer contour. And then for here, I'll go ahead and exit the simulation. The final step is to export the G code. And so from here, I want to make sure that I have all of these highlighted, because if you export the G code but only one of these is highlighted, it's only going to export that operation. So I want to make sure I have everything highlighted, all of my parts. I'm going to go to this G1, G2 post-process. I'm going to select Mach 3. And if you've never done this before, you might have to go into the library, go to the Fusion 360 library, find, you could search Mach 3, and then pick it. And when you do, it's going to ask for like a location, and you want to just go in and pick local. I already have it on this computer, it looks like, so it already has it on my local parts. But let me see if there's one that as an example I could use. Oh, here we go. Okay, so copy post-processor. If you haven't done this before, this will be grayed out, so you can't just automatically pick local. So you have to click from library and then click local and then go select folder. And then you can copy it to your locals. So I got Mach 3 here. I'm going to name it test gusset. And then I'm just going to post it, and then it's going to save that output file into your documents. So if you go to documents, and that's opening it up. But like if I go into my documents and then the Fusion 360 directory, if I go to NC programs, my test gusset is here that I just did, and should be a .tap file. So that's how you go through and cam a part. That way you could cut it in the CNC in the lab.